Well, hello and welcome to the very first lesson of the year in AP Statistics. So today we're going to talk about random sampling and the different methods we have to take a random sample. So you're going to distinguish between different random sampling methods and then describe how to take a random sample in detail and in context, which is a lot of what we do in AP Statistics, is describe things in detail and in context. So firstly, let's just talk about the word random. Hopefully at the end of our first class together, we talked a little bit about the word random and what it means, and maybe a little bit about what it doesn't mean. So random means that something was made or done or is happening or was chosen without method or conscious decision. So sometimes we have this idea that random means that it's fair and that we get all of our groups equally, but random doesn't necessarily mean fair. There's no conscious decision. It means haphazard. It means anything can happen. It means there's no system in place necessarily to pick certain items. We're just picking randomly. So all statistical sampling designs have in common the idea that chance, not human choice, is used to select the sample. So randomized means we let chance do the choosing. This is not about a human element at all. And what that does, the reason randomness is so important in statistics is because it protects us against factors that we know are in the data, as well as factors that we're not even aware of. I'm going to try to describe this quickly, but there's a little photo of a bowl of soup over here. One of our AP statistics textbooks used this analogy of soup. So if we're making a big pot of soup for a bunch of people and we want to taste test it to make sure it tastes okay, what you might want to do before you take a taste test is stir the soup. Stirring the soup kind of makes sure that every little bit of soup is coming out to taste more or less like the entire pot of soup. So if I just finish putting salt on top of the soup and I don't mix it up, my taste is going to be really, really salty, and that's not necessarily representative of the entire pot of soup. Whereas if I stir it, right, I'm making that little top bit that I'm going to taste test from more representative. So we can kind of think of that stirring as randomization. When we randomize, we should, in theory, be getting a taste or a sample that looks like the population. It's minimizing the bias that's happening, right? So factors we know are in the data would be like the salt. Factors we're not even aware of would be like, what if our friend, while we weren't looking, threw a bunch of peas in our soup and we didn't know they were in there? That stirring is spreading the peas around as well. So when we take samples, we don't always think of every single factor that might be important. Randomization is kind of helping with that too. So it's making sure that our sample looks like our population as much as possible. So when we talk about random samples, there are a few different methods that we can use to take a random sample. The first one is what we call a simple random sample, and it's called that, or SRS. We usually abbreviate it. SRS is the simplest, most straightforward way to take a random sample. That doesn't mean it's always easy or like takes a little bit of time. Sometimes it takes a while, but it's the simplest process that we have. It's the most basic, most fundamental. It kind of starts us out, and every other random sampling method is kind of built off of this idea of a simple random sample. So the basic description, and we'll get more specific in a little bit, of a simple random sample is that we number every subject in our population, and then we take a random sample of those numbers. And there are a lot of ways that we can take a random sample of numbers. We'll talk about this in class one day, but we can use a random number generator on a calculator or computer. We can use a random number table. We can roll a dice. We can put a whole bunch of numbers on little slips of paper into a large bucket or hat and draw them out one at a time. Lots of ways that we can use to pick numbers, but with a simple random sample, we're numbering every single subject in our population with a unique number, and then using some kind of method to take a random sample of those numbers. So some advantages of a simple random sample, one would be that every individual has an exactly equal chance of being selected because everyone has a number and we're picking from those numbers. Right. Also, every set of N individuals has an equal chance of being selected. So every group of subjects has the same chance as any other group. Any combination of subjects from a population has the same chance. This one's a little bit more complicated to understand or explain, but think of it as if I were going to pick a group of 10 people from a class of 30, right? That what this means is that picking the first 10 alphabetically in a class is just as likely as picking the last 10, which is just as likely as picking every other person, etc. So any group of 10 from that class has the same chance as any other group of 10. So that's what this is referring to. And this is actually something that is only true about a simple random sample. We're going to talk about several other sampling methods in this video, but that thing about every set or every group of individuals has the same chance, that is only true about a simple random sample. So it's something to keep in mind. Some disadvantages of a simple random sample, or SRS, is that a smaller sample, if we have a really, really small sample compared to our population, may just by chance end up being not super representative. And sometimes it's really, really hard or even impossible to number our entire population, right? Our population might be kind of growing and shrinking a whole bunch, or it's impossible to get them all in one place to number them, etc. There are times when it's difficult to do it this way, so there might be other methods of sampling that are more doable in different circumstances. So let's talk about some of those other ways. So one way is called stratified. Now this is going to involve some grouping, but a stratified random sample means that we're going to first divide our population into what we call strata. Strata would be like homogeneous layers, subpopulations, homogeneous meaning that they are people in our population or subjects in our population that are very similar to each other in some way that we feel is important. So examples of strata would be, we group everyone of the same gender together, so we separate our males and our females. We group same grade level together, freshman, sophomore, junior, senior. We group together people with the same hair color. Maybe we group people of similar ages, etc. Right, so we put people together or subjects together based on some similar characteristic, and then we take a simple random sample from each of those groups. So advantages of stratified. Every group is absolutely going to be represented. If we've split them up into grade level groups, 9th, 10th, 11th, 12th, and I'm picking a simple random sample from each grade level, I am guaranteed to have representation from each grade level. So if I'm doing a sample or a survey or something where it's important that I get input from every grade level, then a stratified sampling is a really good way to do that. It guarantees it. Whereas a simple random sample may not guarantee that. With a simple random sample, I could pick 50 students from McNeil and they could all happen to be seniors. But with a stratified, I'm guaranteed to get one of each group or some of each group. Some disadvantages, there's some situations where we may not have a characteristic that we can split up our groups by. It may not be super obvious. It is also something that can take a lot of time. I didn't put that on here, but that's another big disadvantage, is that it can take extra time. And we don't always have the extra time in our sampling to do that. So another example of a stratified sample, let's say we're polling students about off-campus lunch privileges. We think each grade level has different opinions. Right, so freshmen might feel differently about that than seniors, or vice versa. So by taking a stratified sample, we're guaranteed to get every single grade level's opinions. So our final survey is a lot more representative of the entire student body instead of just pinpointing one grade or another. So we're getting a better sample or survey data. A second type of grouping sampling, so another type of random sample that involves grouping, is called cluster or cluster random sample. In this one, we divide population into what we call clusters, where each cluster by itself is somewhat representative of the population. But I will tell you, generally when cluster sampling is used, it tends to be clusters that naturally exist within our population. So things like city blocks, we might look at each block as a cluster, or pages in a phone book, if y'all know what phone books are. I might look at each page in the phone book as a cluster of individuals, etc. So once I divide my population into clusters, I randomly select one or more clusters. I would do that by numbering each of the clusters, 1 through whatever, and then use some kind of number generator to pick one or more clusters. And then I would take a census, meaning I ask every single individual in each of the selected clusters. So this is kind of a way to make the sampling process a little bit quicker, right? Simple and stratified are both ones that could take a long time because it's a lot of pre-work, numbering every single individual person, dividing them up into groups first, could all take a very, very long time. Whereas cluster sampling, you're only having to number these clusters. And like I said, typically these clusters are already existing in our population. They're already kind of created. So it just makes the whole process a lot quicker. So that's our main advantage. It makes sampling a whole lot easier, especially in that case where natural clusters already exist within our population. It just cuts down the work. So in a school situation, maybe I'm using clusters of second period classes. Right, so maybe I number every single second period class that exists in McNeil, and then I pick 10 of them and I survey all the students in those 10 clusters. Is a really quick way to take a sample. Some disadvantages, and some of you may have thought of this, would be that our selected clusters may not be representative, right? If we're using natural clusters that exist within a population, it's very possible that those natural clusters by themselves don't actually represent the whole. So we could end up with a sample that's not super representative, and that's going to happen sometimes. It makes sampling a lot easier, but it's not always as accurate because we're taking some shortcuts. Right. So another example of a cluster, we want to take a random sample of people that are listed in a phone book. So we choose a random page number. So there's the random, we're using a random page number, and then we're calling every single person on that page. So each page was a cluster. We picked a random cluster and used everybody within that cluster as our sample. A lot of times people will get these two mixed up with each other. It's just a case of kind of remembering which is which sounds easier than it probably is. But when you're thinking about the difference between them, don't necessarily look at just how they're grouped. Sometimes that can be hard to tell. Are they doing similar characteristics, or are they just natural clusters? Look at what happens next. So with a stratified, we're taking a simple random sample from each group. And with cluster, we're using the entire groups as our sample. So that's a big difference between the two. So if you're having trouble deciding which it is, kind of look at that second step, right? After the grouping happens, what happens next? Okay, we're going to kind of more briefly talk through a couple of other types of sampling that we could see in a specific situation. These aren't as commonly seen, but they are used occasionally. So systematic sampling, kind of see that word system means that we have a little bit of a system to it. So systematic sampling, usually we'll randomly select a starting point, and then we select every 10th or 20th or 30th subject afterwards. This works really well when we have a population that's maybe coming in a specific order or in a line, or they're coming throughout the day, something like that, where we may not have all of our population in one place at one time. It's easier for us to kind of do it throughout. So that's a systematic example. I'll give you a couple of examples for that in a minute. So advantages, works well when we have an unknown population size or no realistic way to assign each subject a number, divide them into groups. So one example I like to give is if we were going to take a survey of people who shop at the H-E-B on the corner of McNeil and Parmer. Right, well, those people who shop at that H-E-B are not going to all be there at one time for us to give them all a number and take a simple random sample or even put them in groups, right? But they are going to come throughout the day, throughout the week. So one way to do that population would be to use systematic sampling. Choose a random person to start with and then talk to every 10th or 20th or 30th person who comes in the door. Makes it a little bit simpler to kind of keep track of. Some disadvantages, once you pick that first subject, you're not technically giving every subject the same chance of being selected. So the randomness is kind of suffering a little bit. And it's not always appropriate, but it is a great option to use in very specific situations. So example, I kind of did it one like this with the H-E-B, but if we wanted to poll people who go to the mall on Saturdays, we choose a random number between 1 and 10 to select the first person we talk to, and then we talk to every 10th person we see after that. That would be systematic. Last type we're going to talk about in this video is multi-stage. So multi-stage is pretty much what it sounds like. It means that there are multiple stages. So randomness is involved in more than one stage of the process. This is used often when our population is very, very, very large, and we kind of break it down little by little before we pick our final sample. So generally speaking, I said be careful not to confuse it with cluster sampling. And the reason I say that is because usually in a multi-stage, cluster is like the first step, right? So we might pick a random city block or a random city in a state. That might be our first step. I'm going to number all the cities in an entire state, and I'm going to use a random number generator to pick 5 cities. But then from there, if I do more randomness, if at that point I say, okay, now I'm going to pick a random sample of 100 people from each city, we now have put in stratified within that cluster. So we have multiple stages of randomness where you see a random thing happening in multiple parts. That is multi-stage. So another example with the phone book was what I use as my example for cluster. So let's say we choose a random page from a phone book, that's cluster. But then at that point, I choose a random sample of 10 people on that page. That makes it multi-stage because I've done a random page and then a random sample of 10. Cluster would be pick a random page, use everybody on that page. So you can kind of see the difference. If there's a randomness in more than one stage, it's multi-stage. All right, so those are our types of random samples. So the last thing we're going to look at is how we describe it, because on free response questions, that's what you're going to be asked to do, is to describe how to take a random sample. So let's say I'm going to skip this slide and just go to the example. This will be on the slides for you to look at later for those tips. But let's say I want to describe how to select a simple random sample of 5 students from a group of 30. So this is something you might be asked to do on a free response question. Describe carefully how to select a simple random sample. With this kind of question, we want very, very specific steps. You're kind of telling someone in detail exactly what to do so they can replicate those steps exactly. So, a couple things. I first want to do some kind of assigning. Now, I suggest you stick with numbers. Assign each student a unique number from 1 to 30. Technically, you could also say, make sure all the students have unique names and assign them your unique names. But I find it easier in this description process to use numbers. So assign each student a unique number from 1 to 30. The next thing is we want to say what method should this person who's reading your description use to pick their random numbers. So I like to say use a random number generator. And I put in here in parentheses on a calculator or computer. You wouldn't necessarily need to put that part when you're writing your description. Right, we know where they are, but you can. So use a random number generator to generate 5 unique numbers from that range. And then I said repeated numbers will be ignored. So what's important in this step is to say specifically what method and to say that the numbers you're choosing are different from each other. So you can either say unique or say ignore repeats or both. But we want to make sure that it's clear we want 5 different numbers. Different also works here. So use a random number generator to generate 5 unique numbers from that range of 1 to 30. And then the last thing you want to put in this description is a little context. Context is important in STAT. We always want to tie it back to what the problem is actually about. So at this point, I would say the 5 students whose numbers were chosen will be asked these survey questions, will get a prize, will whatever the problem is indicating that the sample or survey is going to do. We need to kind of finish off our little description by saying that context. Right? So specify the numbers, tell me what method you're going to use to pick the numbers, making sure to say unique or ignore repeats, and then tell me what those chosen sample are going to do. Another way that I could see that used, so I used RNG up here. So here's another way that I could say to do this. So I could say write the students' unique names on slips of paper, put them in a hat, stir the slips to mix them. That includes that randomness piece. Without looking, draw 5 slips of paper without replacement. So that without replacement is kind of the same thing as saying unique or ignore repeats. It means I want 5 different names of students. And then the 5 students whose names were chosen will. So it's just another way you could do it. You could say roll a 30-sided die 5 times and ignore repeats. But you have to make sure and describe what method we're using. And just as a little extra, just to show you, I can kind of use that basis of describing a simple random sample, and I could use that within my description for a stratified or a cluster. So if I wanted to describe how to select a stratified or a cluster sample of 5 students from a group of 30, right? For stratified, I might say stratify by grade level. So let's pretend that there are 20 seniors and 10, sorry, that's supposed to say juniors, 20 juniors and 10 seniors in the class. This would have to be information you were told. I'm just giving you an example. So stratify by grade level, number the seniors from 1 to 20, and number the juniors from 21 to 30. So there's 20 seniors and 10 juniors. I need to fix that. Use a random number generator to choose 3 unique numbers from 1 to 20 and 2 unique numbers from 21 to 30. I picked more juniors because there's more juniors in the class. So I'm trying to make it proportionate. So that would be an example. And then finally, the 5 students whose numbers were chosen will be part of the survey, get a prize, whatever you want to call it. So then for cluster, we might say, suppose the students are seated in groups with 5 students at each table, and let each table represent a cluster. So again, you would have all this information in a given problem. I'm just trying to show you an example. So let each table represent a cluster. Number the clusters from 1 to 6, because there's 30 students total, so there would be 6 different groups. Use a random number generator to choose one number from 1 to 6, and then all 5 students in the cluster whose number was selected will do whatever we're talking about. So those are just a couple of examples of how we can take that general idea of describing a simple random sample and kind of apply it to a stratified or cluster. There's just some things you kind of have to set up. You have to set up the grouping process first and go from there. So that is how we describe random samples, and that is it for this first lesson, which we'll talk more about in class next time.